Welcome children, class 12. Today, second chapter inside the book, that is capacitor and potential, I am going to discuss with you. This is lecture number 1. One by one I shall do this chapter. First, what is the capacitor? Capacitor is a instrument where charge is stored for any for further use. So when you know, when A is a body, now a charge is given to A. Charge given to A. Now potential will increase. Potential will increase. Will increase. Now that means I can say that Q proportional to V, or you can write Q equal to CV. Now C is the unit is, if Q is Coulomb, then V is volt, C is farad. Clear? So C is the capacitance of that plate. Now if another body is brought near A, two plates, suppose A body is kept nearest to A, front surface due to induction will be negative charge and second surface will be positive. Now closed surface, since it is negative, so total capacity of charge A will be indirectly will be reduced. So charge on A will be reduced due to presence of B. Now children, you can tell this positive is far away from that A, but negative layer of the charge is very close to A, so net effect of negative charge will be more than positive one. Another one, if you earth it, so this all positive will go down. So due to introduction of the second plate, net capacity of charge holding capacity of A will increase for the same potential. Again I am telling, suppose a charge is given to A and certain potential is increased. Once you bring another plate, that is the B, then front surface due to induction will be negative and other side will be positive. Now negative side will be very close to A, so net positive charge holding capacity of A will be reduced. You may ask that positive layer will increase the charge capacity, but positive layer is far away from A in comparison to the negative layer. As a result, net effect of the negative layer will be reduced by A. Hence, two plates are used in capacitor. Now, the different type of capacitor under your syllabus, as for example, parallel plate capacitor, spherical capacitor, and cylindrical capacitor. One by one, we shall do all. So, question is given: what is capacitor? What is the dimension of capacitance? You may do. Now, dimension you can do capacitor dimension. Charge Q equal to CV. So this dimension of C will be Q by V. Now you know work done equal to Q times V. Okay, this is work done. Now in that case you are getting V dimension, work dimension by Q. Now W M L square T to the power minus 2, Q equal to I into T. So this V you put here and Q equal to I into T, and 1 by V means I into T by M L square T to the power minus 2. So in that way dimension of capacitance can be calculated. You know work done in electric field is the charge and potential difference. From this expression you can find out the dimension of V. Work dimension already you know, ml square to the power minus 2, and Q is written in terms of current and time, so IT. So from that expression you can find out the dimension of C. So question is here, what is the unit of capacitance? That is a farad. Sometimes mu a microfarad is given, 1 microfarad equal to 10 to the power minus 6 farad. And you can write what is that, why two plates are used. First one plate you draw, then you tell this is the holding capacity of Q and potential is V. Now another body, once you are bringing another conducting material, that is a B, then in front side B will be negatively charged and back side will be positively charged. So negatively are very close to A, so charge holding capacity due to negatively will be reduced for A. So further charge can be given to A. So charge holding capacity of A will increase. Now you may ask why positively are not contributing anything. Positively you are far away from A in comparison to negatively. So this effect will be minimized. Another thing that you just that surface is earth. Once it is earth, so this all positive will be going to go to the earth. So this positive will be nullified. Thank you. Next question I am going to discuss with you, that energy stored in a capacitor. Let us do. Energy stored in a capacitor. Energy stored in a capacitor, I am writing. So energy stored, question number 2, energy. You are writing energy stored, that means suppose Q prime charge is given to a capacitor, clear? Now as a result, potential will increase by V. Now dq prime charge brought brought from infinity. So work done, dw suman charge and potential difference V minus 0. Why V minus 0? You may ask. Potential at infinity it is 0, and anything earth that potential is 0. So dq prime is V. So you write down dw equal to V equal to, you can write Q prime dq prime by C. Now total work done when the charge is given 0 to Q, that is Q prime dq prime by C, it is will come Q square by 2C. How? That is, I am giving you 1 by C and it is coming Q prime square by 2, lower limit 0, upper limit Q. So it is coming Q square by 2C. Q equal to CV, you know, so you are getting CV square by 2. So in that way you can do the net charge. Another method is that first potential 0, another charge you brought, then net potential is V. So average increase, average potential you write down V by 2, and charge is brought Q. So work done will be V by 2, average potential and charge transfer, that is Q. So VQ by 2, and for Q you write down CV, so it is coming CV square. Sometimes you can write by graphical method, you can do also. That means one side is charge and potential V, and that side V, and that is a Q. So if you close area, if you calculate area, will give you work done QV. So this is the energy stored in a capacitor. So when a charge is stored in a capacitor, that means potential energy of the capacitor will gradually increase. So all details you learn, because this is very important in the sense. So those are appearing for any Neet or any Aieee or IIT. So elementary knowledge of capacity is very important. So children, you go through my channel, and if you get benefit, or if you thinking that this channel is helpful for you for any future preparation, then I think you will subscribe my channel and you give some comments for further enrichment. Now this portion again I am telling, Q prime is a given charge to a capacitor, as a result potential will increase by V. Now dq prime charge brought from infinity, so work done, you know, the charge transferred and the potential difference. Why it is 0? Because at infinity it is 0 and you are coming to a potential surface V. So next work done, you are storing the charge from 0 to Q, and after calculating all, you are getting work done CV square. This work will be stored as a potential energy in a capacitor. So you write down U equal to half CV square. This formula must be used, and it will be unit will be joule, provided C is the farad and V is the volt, then it will be joule. Next problem I am going to solve, energy stored in a capacitor I told. Now series and parallel. I am going to discuss basic combination of capacitor, series and parallel. So series combination, you see, series combination very easy for you. Suppose few capacitor in series, C1, C2, C3, equivalent capacitance is C. Now children, it is connected with a battery, voltage V. Then in series combination, Q is same for all capacitor, Q is same, but total potential of battery will be distributed V1 plus V2 plus V3. That means potential will be different. It is plus Q, it is minus Q, it is plus Q, it is minus Q, plus Q and minus Q. Or in series combination, it is potential is different, potential V1, V2 and V3. So you are getting V equal to, you are writing Q by, suppose you are writing Q by C, equivalent capacitance, you are getting Q by C1, you are getting Q by C2, 1 Q by C3. So 1 by C equivalent equal to 1 by C1 plus 1 by C2 plus 1 by C3. So if three capacitors in series, then always remember potential against the capacitor will be different, but charge will be same. Now from that total potential of the battery equal to V1 plus V2 plus V3. Now we are writing, instead of V, Q by C, for the same charge Q by C equivalent, Q by C1, Q by C2 and Q by C3. So this is the formula used for series combination. Now children, parallel combination. Suppose there are some capacitors connected parallel with a battery voltage V. Now this C1 and C2 and C3 in parallel combination, Q is different, just reverse, but V is same for all. V is potential is same for all. Then you can write total charge Q equal to Q1 plus Q2 plus Q3. That means battery charge Q is distributed among the three capacitors Q1, Q2, Q3. That depends on the capacitance value. Now children, you can write Q is equal to C equivalent into V. Potential is same, so you are getting CV1, C2V plus C3V. Then you are getting C equivalent equal to C1 plus C2 plus C3. So in the case of parallel combination, you add all capacitors to get the equivalent capacitance. But in series combination, the reciprocal of equivalent equal to sum of the reciprocal all capacitance. Always remember. So series and parallel combination is clear to you. Now children, very basic capacitor in the same. Capacitor's value depends on the shape and size and what media present between the two plates, that is a dielectric value. Now I am doing parallel plate capacitors general value and parallel plates with the dielectrics. Now children, you know suppose two plates, I am writing two plates plus sigma, this is minus sigma. Now in this case at the point P, electric field equal to sigma by epsilon naught. By Gauss's theorem, I think you have learned electric field here is 0, electric field here is 0, but in the middle it is sigma by epsilon naught electric field. Now from this electric field you can write V into D, sigma equal to charge by area into epsilon naught. So you are getting Q by V equal to A epsilon naught by D. Q by V equal to epsilon by split, that means a capacitor, ER dielectric. ER is there, then C ER will be like this, A epsilon by D. Very easy formula. Now children, energy for that, energy U equal to half C V square. Already you know. So half C value you are getting A epsilon naught by D and V square. V square you are getting, V equal to you are getting E equal to V by E square, D square. Now children, then you are getting half A epsilon naught E square D. So A into D, area into this, area into distance, that is volume. Energy per volume, energy density, electrostatic density, energy density equal to half epsilon naught E square. Very important this one formula. So from that calculation I have shown capacitance for parallel plate capacitor epsilon by D when ER is the dielectric, and after that I have calculated energy density for a parallel plate capacitor. But if whole capacitor filled with a dielectric K, then it will be C prime will be KC0. It will be C0, then KC0, that means dielectric K multiplied ER capacitor KC0. But in general I am doing parallel plate capacitor with composite dielectric. Let us see, it will be elaborative deduction, so I shall take some time. So parallel plate capacitor with composite dielectric we are doing. Let us see. Now composite dielectric, parallel plate capacitor with dielectric slab. So this is the capacitor, area A, it is D, a slab of thickness K P given. So you see that whole slab, whole capacitor having two dielectric, one is here, otherwise is the insulating material, that is dielectric constant K. Now total potential, you write total potential equal to potential for the air, so you are getting E0 D minus T, clear, V equal to E0, for that air it is D, T is the total D minus T, that is for air, and other is the E prime into T. Now children, E prime why? Now in that case if it is positive, now due to polarization it will be negative, it will be positive. So this field will be up to down, that is E0, and polarized field EP will be opposite direction. So polarized, due to polarized field, electric field will be polarized, due to polarization field will be E minus EP. That means field due to polarization. So you are getting E0 equal to sigma by epsilon naught d minus t. It is coming E0 by k into t. Now V equal to, we are getting q by a epsilon naught d minus t plus q by a, that is epsilon naught k into t. Now from that equation you can write, clear, what is the common? You are writing V equal to q a epsilon naught common. In the bracket you are getting d minus t plus t by k. So C is coming a epsilon naught, C that is equal to q by V is coming epsilon naught d minus t 1 minus 1 by k. So this is the formula for if it is a metal, if slab is metal, then k will be infinity. Then C for metal, C metal will be a epsilon naught d minus t. Clear? So again I am telling, this is a parallel plate, plus minus, D is the thickness, A is the area, a slab of thickness T introduced between the plates. Now this dielectric composed two. One is air of thickness D minus T, other is a dielectric slab of thickness T. Now potential, you calculate potential for the slab and potential for the air. Potential for the slab means, potential for air means electric field, the air media E sub is 0, D minus T is the thickness, and it is a polarized field E prime, that can be E0 by k into T. Now Eg suffix 0 knows, since we know E0 equal to sigma by epsilon naught, already from Gauss's law you have learned. So from that consideration I have calculated electric field for dielectric. Now if k is a k made of metal, you will put k equal to infinity. So 1 by infinity 0. So then for metal slab is coming a epsilon naught d minus t. Now I have done some theory. Now I shall do some numericals. First numericals, area is same. First numericals, write down. I am giving you some numericals. One numericals I am giving you. Suppose two area same, thickness, that is common problem. That is it is d by 2 plus this is minus. It is a common line. It is K1 and K2. Now you do this plus, this is common point, this is minus. So one capacitor you can write like this, and this is the another capacitor C1 and C2. So it is clear that in this case two capacitors, it is area is same d by 2. So in that case two capacitors C1 and C2. So C1 you are getting a epsilon naught by d by 2 by d by k into K1. C2 is coming 2 epsilon naught by d K2. Clear? So individual you are calculating capacitance C1 and C2. Now since they are series, so you are getting C equivalent equal to C1 C2 by C1 plus C2. Clear? From that equation C1 and C2 you put it here, then you are getting some answer. You are getting 4 epsilon naught by d whole square by a epsilon naught by d K1 K2, and you are getting multiplying K1 K2. So you are getting this result. So you are adding these two, are 2 is common. So you write down 2 A epsilon naught by D K1 K2 by K1 plus K2. Clear? So if area for your clue, what tips I am telling, if area is same, then they are series. Now children, another problem I am doing, where area here thickness is different, area is same, then series. Now this problem can be solved in different way. I am doing first. Now you suppose you write down in this way, that is plus, that is minus. It is K1, it is K2. Here it is D, it is area A by 2, it is area by 2. Now capacitor, how can we write? Plus, you write down 1 plus, that is 1 minus. That is one capacitor, you write down 1 capacitor, plus minus. That is another capacitor, plus minus. That is C1 and that is C2. So C equivalent, in that case C1 plus C2. They are parallel, so it will be C1 plus C2. Already C1 you put, C1 you are getting A is A by 2, A epsilon naught by 2, D K1. Clear? C2 is getting A epsilon naught K2 by 2D. Put it here, you are getting the answer. So very easy. So this problem for Neet and for any typical exam, that is very important. When thickness is same, then they are parallel. If area is same, then they are series. For your tips, you remember this one. Now last problem I am giving you like this. Problem number 7. It is given, suppose it is 1, it is negative, it is positive. Now clear? It is negative. Now you see there are 3 capacitors. One is positive, you write down positive, there is a negative. So 1 plate, plate number 2, plate number 3, plate number 4. Clear? Now this diagram can be simplified like this. First you see plus and minus. 1, you write down 1. Next with 2, you write down 2. That is C1, 1 is connected plus, 2 is connected minus. Clear? Next 2 and 3, 2 with minus and 3 with plus. So write down 3, that is 2. That is C1, this C, that is C. Next you are getting 3 is plus, already you have done 3 plus. Now 3 and 4. That means there are 3 capacitors, C, C, C. They are all parallel. Here they are parallel. So C equivalent will be 3C. Just plain you are adding C plus C plus C, they are parallel. So these are parallel, so we are getting this answer. Thank you all. If you think this channel is helpful for you, then subscribe my channel and you cooperate with me. Next video I shall do some numericals and some theory, spherical and other theory I shall do on the same chapter, and gradually we should move forward to complete the syllabus. Thank you all children.